Hello and welcome to Call of Chemistry. This will be a second video regarding organic chemistry, some basic principles and techniques chapter of class 11. In this video, we will discuss about IUPAC nomenclature of organic compounds. So let's start. According to IUPAC, nomenclature of organic compound should follow the order. The order is secondary prefix, then primary prefix, then word root, then primary suffix, and finally secondary suffix. Now what does secondary prefix indicate? It indicates substitution of atoms or groups other than the functional groups. And what does primary prefix indicate? It is used to differentiate acyclic and cyclic compound. And word roots tells the number of carbon atom present in the principal chain. Primary suffix indicates either the carbon chain is saturated or unsaturated. And secondary suffix tells the presence of functional groups. We will understand by some examples. Suppose an organic compound has the IUPAC name 2-methyl pent 3-ine 1-ol. Now this methyl represents the secondary prefix and this pent is basically the word root, and it depicts that the chain contains 5 carbon atoms, and ine represents the primary suffix, and it tells that the chain contains unsaturation, and this all represents the secondary suffix, that is here alcohol functional group is present. Now word root guide I have written here that if 1 carbon is there, then it will be meth, 2 carbon are there, then it will be eth, and if there is 3 carbons, then it will be prop, C4 it will be but, C5 it will be pent, C6 it will be hex, if 7 carbons are there it will be hept, and so on. So the initial step of nomenclature is to identify the longest carbon chain, which is called as parent chain. That we have to identify identification of parent chain, that is the longest carbon chain. and after that we have to do numbering in such a way that the substituents get the lowest possible position. The substituents should get the lowest possible position while numbering. We'll understand by an example. So firstly, we have to identify the parent chain. So here we can see that two ways are there of identification of parent chain. That is, one way is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is one type of numbering. And the another way of numbering is that 1, 2, 3, 4, 5, 6, 7 and 8. So this way of numbering depicts that the chain contains 9 carbon atoms, and this depicts the chain contains 8 carbon atoms. So we can see that this will be the correct numbering, and this will be the parent chain. In the next step, we have to do numbering in such a way that the substituents should get the lowest possible position. So here you can see that we can get two possible ways of numbering. One is 1, 2, 3, 4, 5, 6, 7, 8 and 9. And the other way of numbering is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in the first way of numbering, we see that the substituents get the position, that is 2 and 6. And the second way of numbering depicts the substituents have got the position, that is 4 and 8. So this 2 and 6 locant is the lowest locant. So 2 and 6 locant is the lowest possible position. So this is correct numbering, and this is wrong numbering. The next rule says the prefixes are arranged in alphabetical order. That is, we will understand by an example. So if we do numbering, this is 1, this is 2, this is 3 and this is 4. So the IUPAC name of this compound will be 2-bromo 1-chloro butane. As the carbon chain contains 4 carbon atoms, so it is butane. And we can see that here two prefixes are there. One is bromo and other is chloro. And if we arrange the alphabetical order, then bromo will precede chloro. So this name is correct name. Now if the substituent is itself branched, then how we will do IUPAC nomenclature? We will understand by an example. Suppose this compound is taken. Now if we do numbering, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, 8, 9 and 10. Now the rule of doing numbering of branched substituents is that the atom which is directly attached to the parent chain would be 1, then it will be 1, then it will be 2, then it will be 3. Similarly, it will be 1, it will be 2, it will be 3. So this branched group will be named as 1-methyl propyl, because the chain is contains 3 carbon atoms, so it will be propyl. and the name will be 1-methyl propyl, and this group will have the name 2-methyl propyl. Now while doing nomenclature of this whole compound, we see that there is two prefixes are there. One is 1-methyl propyl and the other is 2-methyl propyl. Now in these two prefixes, methyl are common, methyl is common, so we have to give priority that prefix which contains lowest locant, that is here it is 1 and here it is 2, so it will precede the other. So the IUPAC nomenclature of this compound will be 5 1-methyl propyl 6 2-methyl propyl decane. As the parent chain contains 10 carbon atoms, so the word root will be dec. So it is 5 1-methyl propyl 6 2-methyl propyl decane. As this prefix contains the lowest locant, so this precedes the other. Now the next rule says numerical prefixes such as bis, tris, tetrakis are used when the substituent is itself substituted. When the number of substituents is 2, then it will be bis, and when 3 it will be tris, and when 4 it will be tetrakis. We will understand by an example. Suppose we take this compound, so if we do numbering, it will be 1 2 3 4 5 6 and 7. So if we do the IUPAC nomenclature, it will be 4 4 bis 2 chloroethyl heptane. So we can see that the same group is attached in the same carbon, so it will named as bis. And why it is 2 chloroethyl? We have previously mentioned that it will be 1, it will be 2, and similarly it will be 1, it will be 2. The carbon which is directly attached to the parent chain will have the numbering 1, so it will be 1 and it will be 2. So chlorine is attached with 2 numbered carbon, so it will be 2 chloroethyl. As 2 carbons are there, 1 and 2 carbons are there, so it will be ethyl. Now we have to learn the use of hyphen. So a hyphen, so here we see that in this compound there is no hyphen, because this bracket is not followed by a locant. But if we take this compound and if we do numbering, this will be 1 2 3 4 5 6 and 7. So here it will be 1 2, and it will be 1 and 2. So the IUPAC name will be 4,4 bis 2-chloroethyl hyphen 3 hyphen methyl heptane. So here we can see that there is a hyphen is there, because this final bracket is followed by a locant. That is why the hyphen is there. Now we move on to the nomenclature of unsaturated acyclic hydrocarbons. So firstly, we have to identify the parent chain, and that will be the parent chain which contains maximum number of multiple bonds. We will understand by an example. If we take this compound, so this will be the parent chain as it contains the maximum number of multiple bonds. On the other hand, this is not the parent chain as it does not contain any multiple bond. So this will be the correct parent chain and this will be the wrong parent chain. Next we have to do numbering, and we have to do numbering in such a way that multiple bonds gets the lowest set of locants. We will understand by an example. Suppose, so if we do numbering, we can see that we can do numbering in two ways. Suppose this is one way, 1, 2, 3, 4, 5, 6, and the another way will be this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So we can see that in the first way of numbering, the locants corresponds the multiple bond is 3 and 5. In this way of numbering, it corresponds the locant of multiple bonds is 1 and 3. So we can see that between 3, 5 and 1, 3, 1, 3 is the lowest possible locant. So it will be the correct numbering. And it will be the wrong numbering. Now we will discuss a special case. Suppose this compound is taken. We have mentioned earlier that numbering will be done in such a way that the multiple bonds should get the lowest possible locants. So if we do numbering, one way will be this is 1, this is 2, this is 3, this is 4, and this is 5. And the another way will be this is 1, this is 2, this is 3, this is 4, and this is 5. So you can see that in both the way of numbering we get the same lowest locant. In this numbering, the triple bond is in one position, and in this numbering double bond also gets one position, and also in this numbering double bond gets 4 position, and the other way of numbering the triple bond gets 4 position. So we get the same lowest locants. So in that case the priority will be given to the double bond. So the correct way of numbering is this. We have to give priority to the double bond. So double bond gets one position. So this will be the correct way of numbering. The next rule says, so in order to understand the next rule, we will take an example. That is, now if we do numbering, two ways are there. One way of doing numbering is 1, 2, 3, and 4. And the other way of numbering is 1, 2, 3, and 4. So that way of numbering will be correct, which contains the lowest locant of the substituent. Here we see that methyl group is there, so this numbering is correct because it corresponds to the 2 carbon. But the other way of numbering corresponds this methyl to the 3rd carbon, so it will be the wrong and it will be correct. So after taking all these points in mind, if we do the IUPAC nomenclature of this unsaturated acyclic hydrocarbons, it will be hex 3 in 1I. As this carbon chain contains 6 carbons, so what will be hex, and in 3 position there is a double bond, so it will be in, and E letter of the in is omitted, and 1I because in 1 position there is a triple bond. Similarly, for this compound, correct name will be pent 1E 4I. So as this carbon chain contains 5 carbons, so what will be pent, and in 1 position double bond is there, so it will be in, and E letter is omitted, and 4I. And finally, this compound, correct name of this compound will be 2-methyl buta 1,3 di. So as this diene is in terminal position, that's why this E is retained. Now we move on to the nomenclature of compounds having one functional group. When it is the list of the functional group corresponding its suffix name and its prefix name. Prefix name of functional group occurs when 2 functional groups are there. We can see that if acid group is present, then it will be oic acid. Its suffix name will be oic acid. If sulfonic acid group is present, then it will be sulfonic acid. Ester is present, then it will be OAT. Acid halide represents oil halide. Amide represents amide. CN group represents nitrile, and aldehyde group represents al. Keto group represents on, and alcohol group represents all, and amine represents amine. We'll understand by some examples. So we have to first identify the parent chain. Suppose this compound, so this will be the parent chain, as it contains both the functional group and the multiple bond. So that will be the parent chain which contains both the functional group and multiple bonds. But this will be the wrong parent chain. This will be correct parent chain, and this will be the wrong parent chain. So we have taken these 3 examples, and we have to assign the IUPAC nomenclature of these 3 compounds. So first we have to do numbering. So numbering is such a way that is, it is the parent chain, so numbering will be, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So it will be 2-ethyl, as ethyl group is present into 2nd carbon, so it will be 2-ethyl 3-methyl as aldehyde group is there, so the suffix will be al. And if we do the numbering in 2nd compound, it will be 1, 2, 3, 4 and 5. So it will be 3-chloro 4,4 dimethyl Look, this IUPAC nomenclature we are doing, we arrange in alphabetical orders. Ethyl is preceding methyl and chloro is preceding is dimethyl. And in the ester compound, if we do numbering, this will be 1, this will be 2, this will be 3, this will be 4, and this will be 5. So it will be methyl 3-methyl pentanoate. While doing IUPAC nomenclature in ester compounds, this group will be written first. If the rest is same and it is OET, then it will be ethyl 3-methyl pentanoate. So this is written first. Here also this is written first. The next rule says, if in a compound more than 2 similar terminal functional group is present, then none of them is considered as a part of the parent chain. For these cases, different suffixes are used. So, functional groups and suffix. For acid, it will be carboxylic acid, and for aldehyde, it will be carbaldehyde, and for cyanide, it will be carbonitrile. This will be used only if similar terminal functional group is present. Suppose if we consider this compound, so here we can see that same group is present, so none of them are considered as a part of the parent chain. So the numbering is done such a way that it is 1, it is 2, it is 3, it is 4, and the name will be butane 1, 2, 4 tricarbaldehyde. We take another example. Suppose this compound is taken. So here also we can see that same functional group present. So in this case also numbering will be done 1, 2, 3, 4 and 5. So the name will be pentane 1, 3, 5 tricarboxylic acid. Now we will discuss compound containing two different functional groups. When two different functional group will present, then one group represents as suffix and one group will be represented as prefix. And the priority order will be, we will understand by an example. Firstly, look very carefully this list. Here we will do numbering from the acid group because it gets the first priority 1, 2, 3 and 4. So the suffix will be oic acid and the prefix will be formyl. So the name will be 4-formyl 3-methyl butanoic acid. We will take another example. Suppose this compound is taken. So numbering will be done from this side because ketone has greater priority than alcohol. 3, 4 and 5. So here suffix will be on and prefix will be hydroxy. The name will be 4-hydroxy pentane 2-one. Now we will move on to the rules of nomenclature of alicyclic compounds. So firstly, the prefix cyclo is added to the word root. For example, this is cyclobutane and this is cyclopentane, this is cyclopropane and so on. So in that case, numbering will be done in such a way that ethyl should have the lower locant because ethyl comes before methyl in alphabetical order. So numbering will be done from this side 1, 2, 3, 4, 5. So the name will be 1-ethyl 3-methyl cyclohexane. We will take another example. So the preference order will be multiple bond greater than the substituents. So numbering starting from here 1, 2, 3, 4, 5 and 6. So name will be 4-ethyl 2-methyl cyclohex 1-ene. Suppose we have to do IUPAC nomenclature of this bicyclo compound. So firstly we have to do numbering. It is 1, it is 2, it is 3, it is 4, it is 5, it is 6 and it is 7. Then we have to check the number of carbon bridges present in either side. So here you can see that in this side 2 carbon bridge is present because it is 1 and it is 2. So here 2 carbon bridge is present. Here also 2 carbon bridge is present. And here 1 carbon bridge is present. So the IUPAC name will be bicyclo. Then we have to write a third bracket 2, 2, 1 heptane because there are also 2 carbon bridge, here also 2 carbon bridge and here also 1 carbon bridge, and the total system is written in descending order. We have to do IUPAC nomenclature for this compound. So this compound can be drawn that way. So if we do numbering, it will be 1, it will be 2, it will be 3, it will be 4, it will be 5, 6, 7 and 8. So here we see that here 2 carbon bridge is present Here also 2 carbon bridge is there, and here 2 carbon bridge is there. So the name will be bicyclo third bracket 222 octane, as the system contains 8 carbon atoms, so it will be octane. Next example is suppose this compound we have to do IUPAC nomenclature. Firstly, assign numbering. It is 1, it is 2, it is 3, and it is 4. And here we can see that 1 carbon bridge, here also 1 carbon bridge, and here no carbon bridge is there, so it is 0 carbon bridge. It will be bicyclo 110 butane, and it will be written as descending order. Another example is, if we do numbering, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we can see that 1, 2, 3, 4. So here 4 carbon bridge is there. Here also 1, 2, 3, 4. 4 carbon bridge is there. And here it is 0 carbon bridge. So the name will be bicyclo 440 decane. Another example, it is important, that is, if we do the IUPAC nomenclature and we can draw the structure in a simple way, that is, so if we do numbering, this will be 1, 2, 3, 4, 5, 6, and 7. Now we can see that here 1, 2, 3. 3 carbon bridge is there, and here 1 carbon bridge is there, and here also 1 carbon bridge. So the name will be bicyclo 311 heptane. Now we move on to the nomenclature of Spiro compounds. Firstly, we have to do numbering. So it is 1, it is 2, it is 3, it is 4, it is 5, it is 6, it is 7. So simply write Spiro, then third bracket, then see the carbon bridge, number of carbon bridge. So here it is 1, 2, 3. 3 carbon bridge, and here also it is 1, 2, 3. So it is 3 carbon bridge, 3.3 heptane. Firstly, we have to do numbering. So this is 1, this is 2, this is 3, this is 4, 5, 6, and 7. So here you can see that this has 1, 2, 3, 4. 1, 2, 3, 4. 4 carbon bridge, and here also 2 carbon bridge, and it will be Spiro 2.4 heptane. Remember, this will be arranged as ascending order for Spiro compounds. Another example we will take, if we do numbering, it will be 1, it will be 2, it will be 3, it will be 4, it will be 5, it will be 6, 7, 8, 9, 10. Then 1, 2, 3, 4, 5. That is 5 carbon bridge. Here 1, 2, 3, 4. 4 carbon bridge. So the name will be 2 chloro spiro 4, 5. This in ascending order. So by this I am stopping here. If you have any doubt, please let me know in the comment section. Please like, share and subscribe my channel. Thank you.